Bismillahirrahmanirrahim. Assalamu alaikum dear students. I welcome you to the next session of the Linux lecture series. I hope your learning is going fine. And today we are going to talk about links in Linux. Let me move to our board. We're going to talk about links, and why links are used. They are used for sharing of files. Sharing of files. While sharing of files on multi-user system is desirable, and it can be done through duplicating files. It can be done through common login for team members. It can be done through common groups for team members, and this I think has been covered in the user management lecture. Sharing of files can also be done by setting appropriate access permissions. By setting appropriate access permissions. Well, in the next session, inshallah ta'ala, we will be touching upon the access permissions as well. And today we are going to talk about sharing of files using links. And we have two kinds of links in almost all Unisystems. One is known as the hard link, and the other is known as the soft link. And before I move on to the terminal and start doing with the hard and the soft link, let me draw a diagram and make you understand how the hard link actually work. Hard link. Right, let us consider a directory D1, and let's suppose that this directory contains just one file with the name of F1 having, let's suppose, the inode number 47. I hope you understand this from the previous lecture. And let's consider the linear view of the disk partition having the boot block, the super blocks, and a lot of inode blocks, and we have space for the data blocks as well. And this F1 has having a inode number 47. Let me change color. This 47, and this 47 inode block contains all the metadata of the file F1, and it is pointing to one or more data blocks which contains data of this file. So this was how the file was created, by creating an entry in this directory by assigning a free inode number and inode block and one or more data blocks. Once you want to create a hard link, the command that you use is ln. You say the name of the file F1, it is in the present working directory, and then you write down the name of the link. Let's suppose hard link hl to F1. I've just created both these files in the same directory for just better understanding. So by doing this, another entry in this directory will be created, and with the same inode number. Now whether you cat F1 or you cat hard link to F1, whether you do vim F1 or vim hl to F1, actually this data will be displayed and this data will be edited respectively. So this is what a hard link is. Let me do it on the terminal. Okay. Okay, fine. So we are going to talk about the hard links, and we have seen it on board, and we have made a bit of understanding of it. Let me come over here and let me clear the screen and let me do ls. Okay, we have a lot of files over here. Let me do see the long listing. If we see the long listing, you can see all the 7 file types in this directory. The regular files, where we have a dash representing the regular file, a directory, we have a D. Here we have a link with an L over here, the block and the character special files. We will talk about these inshallah ta'ala in some next session. The name pipe or the FIFO, we have talked about this, and then finally socket and S over here. So we have 7 different file types in this directory. So let me make a directory dir stds students, and let me cd to students. So I'm in directory students. So let me create a file in this directory. I say echo learning Linux is fun with Arif, but it is fun for me, but I don't know about you. Let me put this in F1, and you can see we have a file F1, and we can see this file F1 contains some data. You can see the character 37 over here. Let me cat F1 and it is visible. Okay, so let me create a link using the ln command, F1 the name of the actual file, and hard link to F1. Okay, so now this is created, and you can see both these files have the same inode. Both of them have same inode, whether you access via name F1 or you access via name HL to F1, the same inode block and the same data block will be accessed. And this is what is happening over here. Cat F1, cat hard link to F1. You are accessing the same data. So keep noting things, that this is a link, but this is represented by a dash. So remember, hard links are represented as regular files. You can see same permission sets. If you change permission on one file, permission on other will also change, as there is only one inode block. So whether you change permission for F1 or you change permission to HL to F1, the permission changes take place in this inode block. So you can see the same thing over here as well. This is important thing. This is known as the link count. You have not seen this more than one before. Over here you are seeing it 2. So if I create another hard link, let me say another hard link, and now if I do ls-li, you see a 3 over here. So as I keep on creating the hard links, the link count keeps on increasing, and as I keep on deleting the hard links, the link count keep on decreasing. Let me remove a hard link. Okay, that's very fine. So the hard link keeps on decreasing, but this data blocks stay there. The hard link keep on decreasing, and the data blocks will be deleted only if the link count reaches 0. And one more important point, if I delete the original file, even then you can access the data. Let me do that over here. If I delete F1, you see F1 is deleted, but I still can access the data using HL to F1. I have deleted this F1, but this entry is still there, so I can access the data. That means these links are not the actual links, the same links which you are used to in Microsoft, where if you delete the original file, the link becomes a dangling pointer. Okay. So one last thing, that if you change timestamps as well, you change timestamps on one file, timestamps on the hard link will also change. And The data blocks are removed only if I remove the hard link as well. So now I have removed the hard link. There is no entry in the directory, so we have nothing over here. The limitations of hard links are you cannot have hard links to directories, and you cannot have hard links across partitions or across network or across other file system. Let's check this out as well. mkdir d1, we have a directory d1. Let me try to create a hard link to d1, hard link to d1. So it says hard link to directories not allowed. Okay, fine. So after doing this with the hard links, let's come back on the board and talk about soft links now. So if I talk about the soft links, let's see the diagram first. Let me take yellow this time. Soft links. Let me have a directory again, the same directory, let's suppose D1, and let's suppose that I have a file F1 with the inode number 47. Keep the same example so that we can understand it a bit better. Here is the linear view of the partition on which we are, the boot block, the super block, and a lot of inode blocks, and then we have the data blocks, and here we have 47. Let's suppose this time this is 47 in yellow, and this is the data block of 47. Now what we do is we create a soft link. Let me create it with the blue color this time. The command to create a soft link is again ln, but you give a -s option to it, name of the original file, and then name of the soft link, sl2f1. So I say ln -s f1 sl2f1. So another entry is created in the directory sl2f1 with a different inode number. Let's suppose 100. So we have a inode number 100 over here this time, and this inode number 100 is pointing to a data block which is containing something in whose detail I'm not going right now, and at the end this is pointing to inode number 47, and which is pointing to the data block. So try to understand. Now if I try to access data using F1, that is very trivial, but if I do cat SL to F1, I will come through this path, this 100, and I will come over here, and from here I will come to inode number 47, and from inode number 47 I will come to the actual data block. So this is what a soft link is. Let's try this out on the shell for better understanding. Let's try this out over here. Right, gentlemen, soft link. The command to create soft link is ln hyphen. Let me use the previous command. I've used a lot of commands. Yes. We have a file right now, f1, and its inode number is 7065. Let me create a soft link this time to f1 with the name of sl2f1, and now once I say ls-li, so you see we have different inode numbers. f1 has an inode number of 65 while soft link has an inode number of 66. So the original file is having a different inode and the soft link has a different inode. Let me move this to somewhere else. Okay, so we can access the files data using F1. We can access the file data using soft link to F1. So up till here there is no difference between hard link and soft link. So let me clear the screen, ls-li. So we have different inode numbers. Then the important thing is that you see this is a regular file, F1 represented with a dash, and soft link is a link represented with an L. So this is actually a link. Next is the permission set. We have different permission sets on F1 and we have different permission set on the soft link. Right, gentlemen, remember permissions on soft link are irrelevant since the permissions of the target apply. The permission on the soft link are irrelevant. Whenever you make change, the changes actually happen inside the actual inode block. The next important thing is that if you see over here, the link count is 1. If you delete the soft link, the original file is still there. If you delete the soft link, this entry will be deleted, this inode block and this block will be deleted. The data will still be accessible. Let me do that for you. Let me remove this soft link and we do F1. It is still available. Let me again create the soft link and let me delete the actual file this time. And if I delete the actual file, the soft link has become a dangling pointer. Now if I do cat soft link to F1, it says no such file or directory. So if I delete the original file, let me do that over here. I have the facility of a rubber as well. Let me delete the original entry. So this entry is no more in the directory. If this entry is no more in the directory, that means this inode block is also not there, this link is also not there, and this is also not there. Now what will happen is, once you do cat soft link to F1, you do cat soft link to F1, you come over here to 100, from 100 you come over here in this data block which contains some management data, and then you try to go to inode 47 which is not occupied now. It's not pointing to actual data block. So that is why you see the message no such file or directory. And finally, remember the timestamps are on the soft link and the original file. Whether you touch the soft link or you touch the original file, the timestamp of the original file actually changes. And as we have seen the limitation, we can have symbolic link to directories. Let me do that as well. Let me remove this. Let me make a directory DDD and let me make a soft link to this directory using ln-s. Directory name is dd and the soft link name is sl2dd. And you can see we have successfully created a soft link to directory. So that is all about today's session. Today I just wanted to tell you about the links, and I wanted to tell you that you can use hard as well as the soft link for sharing of files. And sharing of files can be done with other ways, but we have seen the hard link and the soft link. And finally, to the Microsoft users, remember the links that you use, the shortcuts that you use in Microsoft Windows are the same as the actual soft link in Linux. I hope it was informative. I wish you all the best. Happy learning and Allah Hafiz. तुम ही से ऐ मुजाहिदो जहां का सबात